Hello, ladies and gentlemen of Algebra 2. You are looking at 6-2 right triangle trig. If it looks familiar and maybe it brings back a few nightmares, that's because you have seen this before in geometry. This is kind of a recap and a revisit to what we were talking about there. So let's start with kind of a good example here. The Americans for Disabilities Act provides regulations designed to make public buildings accessible to all. So that means you have to have ramps. So the mobility disabilities must not exceed a ratio of 1 to 12. That means for every 12 units of horizontal run, the ramp can rise or fall no more than 1 unit. So if the ramp is 12 inches, for every ramp that the 12 inches goes up or down, or goes out, it can go up or down no more than 1 inch. So if I take a look here, I've got this ramp that's 12 feet by 1 feet. So I'm trying to figure out the actual length of the ramp, so I'm actually trying to figure out that. Well, that's nothing more than good old Pythagorean theorem, where I just go 12 squared plus 1 squared equals c squared. So it's 144 plus 1. So that's going to be 145. So to solve, I take the square root, and square root of 145 is going to be 12.04 feet. So slightly more than 12 feet, not exactly 12 feet, but slightly more. So then they want you to figure out, what is the measure of angle A? What is that tiny little measurement in there? So here's where we have to use trig. So I'm looking for that angle. That's 12, that's 1. So from this angle here, okay, this would be the opposite side. This would be the adjacent side. And for those of you guys that don't remember, SOHCAHTOA, opposite and adjacent means I need tan. So I'm going to take tangent of what we call theta, and that's usually what we name the angle that we're looking for, equals opposite over adjacent. So I'm looking for that. Let me figure out this whole thing here. Let me do that. So to solve, I take what's called the tangent inverse of 1 over 12 and solve it. So tangent inverse of 1 over 12 is going to be about 4.76 degrees. So a very, very slight degree measure to go up there. So sine, cosine, tangent. The word SOHCAHTOA is something that you guys should have heard before and should honestly remember very, very well, because that's going to be what you're with. So sine, cosine, tangent, and then you have the reciprocal functions, which is just flipped over. So for the sine of A, I'm looking from angle A, this would be the opposite side, this would be the adjacent side, this would be the hypotenuse. So opposite over hypotenuse is just going to be A over B. Adjacent over hypotenuse is going to be B over C. Opposite over adjacent is going to be A over B. Now I'm looking at all this from the perspective of A. So then over here, reciprocal functions, this is called cosecant. All right, so this one's called cosecant. And it's just flipped over. So this is just going to be B over A. This is called secant. And it's just flipped over, so it's going to be C over B. And this is called cotangent. And the easy way to remember all of these reciprocals is that when you match them up, each one has only got one co. All right, each one has only got one co. Let me slide this up here. So you've got sine, and the reciprocal is cosecant. You have cosine, and the reciprocal is secant. You've got tangent, and the reciprocal is cotangent. So in each one, you've only got one co. All right, so that's kind of how you remember that. So reciprocals just mean flipped over. So SOHCAHTOA, find the 6 trig functions, find the 6 values for the trig functions here. So the sine of theta is from here. I'm looking from angle C. So from here, this would be opposite, this would be adjacent, this is going to be the hypotenuse. So the sine of that is going to be 4 over 5. And then cosecant is just that flipped over 5 over 4. Cosine is going to be 3 over 5. So flip that over, you get 5 over 3. Tangent is going to be 4 over 3. So flip that over, that's going to be 3 over 4. All right, all I'm doing is looking at the ratios, the values of the side relationships. So if the cosine of A is 2 over 5, figure out what the tan of A would be. Well, start off by, let's draw a triangle here. So I've got a right triangle. We'll call this A, call this B, call this C. Cosine of A is 2 over 5. So cosine means adjacent over hypotenuse. So that means that's going to be 2 over 5. So then how can I figure out this side? Well, good old Pythagorean theorem always works. So that's going to be, when I do Pythagorean theorem, that's going to be 4.582. So that's that length right there. So when it looks for the tangent of A, so that means the tangent of A would be that. Tangent of A would be equal to opposite over adjacent, so that'd be 4.5825 if I really want to go out a couple decimal points, over 2. So all I did was draw a triangle, use it to figure out what I'm dealing with. So tangent of B, same idea here. I'm going to draw a triangle. So if I call this one B, call that one A, call that one C. Tangent of B means opposite over adjacent. Then use Pythagorean theorem. Don't use quadratic formula. That will be really wrong. Gives me this for a hypotenuse. So figure out the sine of B. So the sine of B then is just going to be opposite over hypotenuse. So that's going to be 3 over 7.616. There's my answer. So if it just says solve for x, here's where I got to start. I got to start with looking at what am I dealing with, and what's my side relationship. So if I look, I have this angle. From this angle, this is the opposite side. This is the hypotenuse, because the hypotenuse is always hypotenuse is always hypotenuse. Opposite and hypotenuse means sine. So the sine of 20 is going to be equal to x over 15. So now sine of 20 actually has a value. You put in a calculator that's in degree mode. Okay, make sure your calculator's in degree mode. You get a decimal. That's 0.3420 x over 15. So take that answer times 15, and I get x to be 5.13. So there's my answer. So check and make sure that your calculator is in degree mode, so you know what you're doing with that. So figure out x, y, z. So find all the sides and angles we don't know yet. So I know this angle and I know this side. So I'm going to figure out what z is first. So this would be the adjacent side, opposite side, hypotenuse. Okay, so I want to take the sine of 35, because the sine of 35 is going to be 10 over z. And algebraically, what happens, because I have the z in the denominator here, if I solve it algebraically, all that really happens is that these two things switch places. So I end up with z with 10 over sine of 35 is equal to z. So take 10 divided by the sine of 35, and you get 17.434. So that's how big your hypotenuse is. So your hypotenuse is going to be 17.434. So that answers that question. Now if I want to figure out the opposite side, I have two choices. I can do Pythagorean theorem. All right, I can do this squared, and figure out what that is. Or I can use trig. So if I take the cosine, oops, I screwed that up. I'm sorry. I should have done cosine over here first. I really biffed that up. I apologize. I should have used cosine. I actually solved what I actually solved for. I couldn't have solved for that. I should have used cosine here and cosine here for 35. That's what I should have done. 10 divided by cosine 35. So that makes that one, so that makes that one 12.20. So that makes z 12.20. My apologies. Wow, that was an epic screw up on my part. So now, figuring out this side, now I want to use sine or tangent because I'm trying to figure out the opposite. I want to use tangent just because, you know, I like the idea of having the adjacent there. So tan of 35 equals x over 10. Tangent 35 times 10 is going to be 7.00. So basically 7. So this is going to be 7. So how do I figure out this last angle measure that they're looking for? How do I figure out this? Well, a triangle never changes. It's always got to add up to 180. So I take 180 minus 90 minus 35. So I get this angle measure has to be 55. So now we have all the pieces of the. So in order to construct a bridge, they have a distance of 50 meters to the left of the stake. An angle of 82 degrees is measured between the stakes. Find the width of the river. So we're trying to figure out this. So from 82, this would be opposite. This would be adjacent. So opposite and adjacent tell me tangent. So the tangent of 82 has got to be equal to W over 50. Tangent of 82, put that in your calculator. Then multiply it by 50. Then I get 355. So figure out, do algebra. 355.768. So it's going to be 355.768 meters across that river. So John found two trees directly across from each other in a canyon. When he moved 100 feet from the tree on his side, the angle formed with the tree was 70 degrees. So that means you have a tree here, you have a tree here, you know, and here's the canyon. Then he moved 100 feet this way, and he figured out that this angle created is 70 degrees. So he went perpendicular. So then he wants to figure out what is this distance across the canyon. So from this angle, this would be opposite, this would be adjacent. So again, I want the tangent of 70 is equal to x over 100. So tangent of 70 times 100. That's going to be 274.75 feet. There's my answer. All right, come talk questions. Hopefully this isn't completely new to you. Hopefully you at least recognize this as a big part of geometry. Come talk to me with questions and make sure that your calculator is in the right mode.